The atmosphere of Earth is composed of a layer of gas mixture that surrounds the Earth's planetary surface, both lands and oceans, known collectively as air, with variable quantities of suspended aerosols and particulates, which create weather features such as clouds and hazes, all retained by Earth's gravity. The atmosphere serves as a protective buffer between the Earth's surface and outer space, shields the surface from most meteoroids and ultraviolet solar radiation, keeps it warm and reduces diurnal temperature variation, temperature extremes between day and night, through heat retention, greenhouse effect, redistributes heat and moisture among different regions via air currents, and provides the chemical and climate conditions allowing life to exist and evolve on Earth. By mole fraction, i.e., by quantity of molecules, dry air contains 78.08% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and small amounts of other trace gases. Air also contains a variable amount of water vapor, on average around 1% at sea level, and 0.4% over the entire atmosphere. Air composition, temperature, and atmospheric pressure vary with altitude. Within the atmosphere, air suitable for use in photosynthesis by terrestrial plants and respiration of terrestrial animals is found only within 12 kilometers, 7.5 miles, from the ground. Earth's early atmosphere consisted of accreted gases from the solar nebula, but the atmosphere changed significantly over time, affected by many factors such as volcanism, impact events, weathering, and the evolution of life, particularly the photoautotrophs. Recently, human activity has also contributed to atmospheric changes, such as climate change, mainly through deforestation and fossil fuel-related global warming, ozone depletion and acid deposition. The atmosphere has a mass of about 5.15 times 1018 kg, 3/4 of which is within about 11 kilometers, 6.8 miles, 36,000 feet, of the surface. The atmosphere becomes thinner with increasing altitude, with no definite boundary between the atmosphere and outer space. The Kármán line, at 100 kilometers 62 miles, or 1.57% of Earth's radius, is often used as the border between the atmosphere and outer space. Atmospheric effects become noticeable during atmospheric re-entry of spacecraft at an altitude of around 120 kilometers 75 miles. Several layers can be distinguished in the atmosphere based on characteristics such as temperature and composition, namely the troposphere, stratosphere, mesosphere, thermosphere, formerly the ionosphere, and exosphere. The study of Earth's atmosphere and its processes is called atmospheric science, aerology, and includes multiple subfields, such as climatology and atmospheric physics. Early pioneers in the field include Leon Tysserin de Bort and Richard Assmann. The study of historic atmosphere is called paleoclimatology.